In this video, I will discuss some common errors and warnings faced during Abacus simulation and how to go about handling those. I will discuss ways to diagnose the errors, some errors related to step size, like those throws the error message saying too many increments needed to complete the step, or time increment required is less than the minimum specified. I will also look into another step size related error that says too many attempts made for this increment and what you can do to resolve this. Finally, I will comment on some common warning messages. The first thing you do after an Abacus job is aborted is to check the error message and warning message. This job, Hill 48 2D, has aborted. We can immediately see several errors in the message here. The first error saying time increment required is less than the minimum specified. So this is the main error why this job has been aborted. And there are supplementary information saying the analysis has been terminated due to the previous error. And there are even a further error message. Maybe it doesn't say too much, but here you would get the preliminary or most important error messages to know the cause for aborting this particular job. Then if you right click on that aborted job and monitor, then it will give you a pop-up, and there you will see that there are several tabs. One of them is error. It gives the same error message or all the error message that has been printed here. At the same time, it will additionally give you all the warning messages. For example, we read one warning message that says the strain increment has exited 50 times the strain to cause the first yield at 998 points. The outputs from this job has been saved in this folder. So here you will find some files by the same name as the job name. So the job name was Hill48_2D. So in this folder you will find a .msg or message file. Also you will find a .dat file by the same name as the job. So this file and this file will also contain important information about the cause of the error. Let's open this .msg file. And if you go towards the end of this file, you will find that this error message is also printed here with some additional information that the solution appears to be diverging. But why these errors are occurring, those we will see soon. But for now, these are the ways that you can diagnose the reason for the error or why the job has been aborted. In addition to .msg and .dat file, you can also look into .stf file if really needed. Let's now address this step-related error saying too many increments needed to complete the step. You specify the maximum number of increments in step. So initial step is by default. The step 1 is our solution step. Click there, then go to incrementation tab, and here you can find maximum number of incrementation. By default it is 100. Sometimes your solution could be highly nonlinear and the number of incrementation that's needed to complete the job is commonly can get higher than 100, and if it goes beyond 100 you will get the error too many increments needed to complete the step. So to make sure that you never get this error, put several zero right after that. So I have made the maximum number of increments to be 10,000. So I can be quite sure that the increment number will not cross this number, and we will never get this error related to maximum number of increments. Next error is time increment required is less than the minimum specified. You will specify the minimum time increment here. So by default it would be 1 e to the power 5. So to be safe you can make it 1 e to the power minus 15. So if you go to basic, if your time period is 1 and the unit is second, then this means that for a particular increment, the minimum could be up to 1 e to the power minus 15 second. So this is useful where you have very harsh non-linearity and the simulation needs very small increment to overcome or solve around that non-linear region. So I would say the best practice in step increment incrementation is to make the maximum number of increment around 10,000 and make the minimum increment size 1 e to the power minus 15. So given that everything else is okay with your model, you will never get this 2 error message if you fix the incrementation accordingly. Now let's look at this error, too many attempts made for this increment. If we look at that particular example, that there was an error, and that error happened when increment number 11, the solver made 1, 2, 3, 4 up to 5 attempts. So after 5 attempts, the solver throws an error. If we look at the particular job that is aborted, and we can go to monitor. Here we can see for increment number 38, the first attempt was made and the time increment was 1 e to the power minus 6, and then it did not converge. So it made a second attempt, and that time the time increment was reduced by 4 times. So it was 1 e to the power minus 6 and it becomes 2.5 e to the power minus 7. So the solver tries to reduce the time increment and to see if it can reach any solution. So this is our first cutback from first attempt to second attempt, and then another cutback was used in this increment number 38 from second to third attempt, and again in this time for the third attempt the time increment was reduced by 4 times again. So during these 2 cutbacks, the time increment for increment number 38 has been reduced from 1 e to the power minus 6 up to 6.2 e to the power minus 8. So that is about 16 times. And by reducing it to 16 times, the solver could overcome the non-linearity that was occurring at increment number 38. So by default, the number of attempts are 5. So the solver will try to cut back up to 5 times, and each time reducing the increment size by about 4 times. Just using 5 cutback attempts might not be sufficient to overcome some of the non-linearities. So if you give the solver the flexibility that if required in some increment that cutback attempts are higher, such that the solver reduces the minimum time increment lower until it gets a convergence, then you increase your chance to get the convergence in the overall job. But as I said, the default number of cutback attempts are 5. You can increase the maximum number of cutbacks by going to step module and then others and then general solution control and then edit and selecting your particular step, in our case step 1, then going to time incrementation tab and then going to more tab, the second tab, and then adjust the value of IA. Let's see how it looks in Abaqus. So here we are in job module. Let's go to step module and then we will find this other tab. Go to general solution control, edit, and we will edit our step 1. And in that there is a warning. Of course, these are for advanced users. So continue. And here in this second tab of time incrementation, if we go to this more or the second tab, then we will find this IA, and it says that the maximum number of cutbacks are 5. So just we cannot edit it right away. We have to go to specify, tick that, and after that it is possible to edit the field value. So let's make it to be say 15. And by that we are allowing Abaqus to use more cutbacks and at the same time giving it more possibility to converge to a solution. So far we have tried to tackle this particular error message of too many attempts. We have literally eliminated these 2 errors, that they will almost never happen by reducing the minimum time increment and also by increasing the maximum number of increments. But for this error, of course, we made an attempt to eliminate by increasing the number of cutbacks, but it is not certain that eventually you will get a convergence of your job, because there is a root cause, and some of the root causes are instability in hardening. That's what happened in our particular case. And then too large applied strain. You have to check the material definition, that this is not impractical. You have to look for consistency in the property of this material, check the boundary condition, and sometimes damping might help to overcome this sort of non-linearity. So I will briefly show you what I mean by instability in hardening and how you can overcome sometimes including some sort of damping. So in this particular job, the reason for aborting this is, of course, time increment required is less than minimum specified. But again, the time increment, if we look in monitor, when the job aborted, the time increment is 1 e to the power minus 15, which is really low. That means although it's showing that it aborted due to time increment is less than 1 e to the power minus 15, but practically this error occurred because I had instability in hardening. So in here, in the material definition, in the plastic hardening data, so we have defined that with increasing plastic strain, the yield stress decreases. So by that, there is an instability in your material data. So there's some inconsistency in your material property definition. So that was the root cause for getting our job aborted. One can also make an attempt on the step, and in here automatic stabilization, if you include some sort of damping factor, you can accept the default. By doing so, you can increase your chances to overcome some of the errors that might occur. Be careful when you are using this sort of damping factors. Now let's talk a bit about the warning message. You can get some common warning message. The strain increment has exceeded 50 times the strain to cause the first yield at 256 points. So don't think about the points. This point number could vary. I also for this job got similar exiting 50 times the strain to cause first yield, but in this case it was 998 points. Many a times this is not critical. You can also have the eigenvalues are negative in several points. These are most of the time are not critical, but yet the cause for those is of course this excessive or unrealistic loading, inconsistent value of material properties, insufficient mesh refinement, and unstable deformation such as buckling. So in our case, it happened because we had inconsistent value of material properties that I showed you earlier. The hardening is not appropriate. Finally, let's talk about a special error message, error element related to element property. And then it says the element has been identified in the element set, and there is a name for that element set. The name starts with ERR error element and follows. So sometimes you might get that message and you might wonder that where you can find that error elements. To find those elements, you have to go to the job, results, and when you are in result tab, in the result tab for the job Hill 48 2D, you will see we have element set and node set. So if you have any sort of error element set, so they will be appearing here. Then you can just double click on the name of that error element and it will highlight those particular elements. In this case, I have highlighted all the elements, but if you have the error element, they will highlight only those elements having the error. That's all for today's video. Good luck with your simulation.